Alright guys, today we're going to look at properties of logarithms. And our objectives are to use properties of logarithms to write equivalent logarithmic expressions and to find their approximate values. That equivalent logarithmic expressions, what do I mean by that? I'm looking for us to be able to write things either in a condensed or an expanded form. That's what I mean by that. And then we'll find approximate values of logarithms and solve logarithmic equations. Those are objectives, so let's get started. With this first property here, we're told that if we have a positive base, and it's not 1, and a positive x value, that these two logs would be equal to each other if and only if x and y were equal to each other. So same bases for your logs. They'll be equal only if those x and y values were equal to each other. That's going to come in very handy as we work to solve logarithmic equations. And we're actually going to prove that together, but not in this video. I have some more properties, and I'm going to show you that these properties of logarithms, they really do stem directly from properties of exponents. You're going to see a lot of similarity there. So let's begin with the product property and take a look at what that is for exponents. Remember, if you're taking the product, same bases, you add your exponents. So if you're taking a log with the same base, you would multiply m and n, or you could take your logs separately and add them together. You see how that's kind of similar? If you're multiplying product, the way that you would write that is by addition, by adding your two logs. Similarly, we have our quotient property. If you had the same base being raised to both m and n, and you're taking the quotient there, you would just subtract those exponents. And here, if you're taking the log of a quotient, you can separate that out. You can expand that by taking log of the numerator minus log of the denominator. You see, kind of just really very similar to that exponent property. And lastly, we have the power property. If you're taking something that's been raised to a power and applying another power, all you do is multiply. And that is true with your property for logarithms. You're taking the log of m, and m is raised to the power p. Well, ladies and gentlemen, all you have to do is take log of m and multiply it by p. So those are our properties. We will be proving those together, but not in this video because it's quite a lengthy process. But we are going to look at applying them in this video. So let's get started. We're going to write this first expression as a single logarithm. This first example, example 1, we're going to do part A and part B. So let's work A. Log of 32 base 2 minus log of 8 base 2. The logarithms that we're looking at here, they both have the same bases, so we could condense this and write it as a single expression. And that will be done by applying the quotient property. Because we are subtracting those two logs with the same base, we can just express this as the quotient of what we're taking the log of. So that's log of 32 over 8, and we are working in base 2. You could simplify that. 32 divided by 8 is 4. So this expression can be written as log of 4 base 2. That is a lot simpler than what we were first presented. Here in part B, we're looking at 3 log x base b plus log of y base b. And we can express this as one expression because we're working with logs of the same base. The first thing we'll do is apply the power property. With that 3 out there in front of your log, really what that means is that your x is being raised to the third power. So now it is placed in that exponent position instead of in front of your logarithm. That's an application of the power property. And now we'll be able to apply the product property. Because we're taking 2 logs, same bases, and adding them, you can just go ahead and multiply those values. So it's log x cubed times y, and that is in base b. Now let's look at this example. What we're going to do here is just the opposite. We're given one expression and we're going to expand that out. And it could be kind of perplexing. Where do I start? Well, you'd want to start with really kind of the largest element there, which everything is being taken inside of that root, correct? It's actually a cube root. That's why there's a little 3 right there. That's your index. We can rewrite that. When you're looking at the cube root, you can write that actually in an exponent, and it would be to the 1/3. It's just the inverse of cubing, right? Taking the cube root is the inverse of cubing, so we have just taken the inverse of cubing, which is 1/3. The inverse of 3 is 1/3. So now let's apply the power property. So that power is going to be placed in front of your logarithm. You're going to multiply that whole log by 1/3. Now, you'd want to work with that quotient. You're taking the quotient of d squared over c, and we're going to expand that out and write it as subtraction, because when you're using division, the corresponding operation when you're working with these logarithms and exponents is subtraction. So it's 1/3 of this whole thing, log d squared base 3 minus log c base 3. And the only thing left is that d is squared, and we can't have that. We want to apply the power property again, and so that 2 is going to go in front of the log, and it's only applying to that first log. So that would be your final answer. You'd have 1/3 of that whole statement, which is 2 log d base 3 minus log c base 3. Now you might be wondering, why would I go through all this process of expanding? Well, what you'll probably be given is something like this. And I remember actually seeing this on one of my, I don't know if it was my SAT or one of my college placement tests. I remember this problem and I didn't know how to do it, and I went and I tried to figure it out. And so I'm going to help you guys and teach you it now. You're given what log 5 is, and you're given what log 7 is. They didn't tell you the base here. It's okay. They're assuming that it's the same base. What we want to do is find a decimal approximation for this logarithm, log 175. You're like, well, I don't know. I don't know what it is. I only know log 5 and log 7. How am I supposed to know log 175? Well, ladies and gentlemen, express 175 in terms of 7 and 5. 175, if you factor it using your factoring tree, log 175 is the same thing as 5 times 5 times 7, which would be 5 squared times 7. 25 times 7. You can check that right now. I encourage you to do so with your calculator. Now the expression that we have only has 5 and 7. And we can use our properties. We'll apply the product and the power property to expand that out. So that would be log 5 squared plus log 7, right? Because when you see that multiplication, you can expand it using addition. And then that exponent of 2, that's going to go in front of that first log. Now, ladies and gentlemen, it is 2 log 5 plus log 7, and we can substitute in our values here because log 5 is 0.699 and log 7 is 0.845. So it's 2 times that first value plus the second value, and there you have it. It is 0.301. So there you have it. An application of using properties and solving for this logarithm to find its approximate value. That is all I have for you guys. Thank you.